Hi, my name is Jenica, and for my OS project, I wanted to implement a file system. After doing some research on how to go about implementing a file system, I came across the Fuse libraries. So Fuse stands for File System in User Space. It allows the implementation of a file system without actually having to write any kernel code. The libraries are available for Linux and Mac OS. And so the two main components of the Fuse libraries is the Fuse kernel model and the libfuse library. So what this diagram is showing is that the file system code is implemented in user space, and the Fuse libraries bridge that code to the actual kernel interfaces. So Fuse offers two APIs, a high level and a low level. In my project, I'm using the high-level API, which is found in the fuse.h file. There's a Fuse operations struct in the header file that contains file system operations. And so all the fields in this structure are pointers to functions, and these pointers will be called by Fuse when something happens on the file system. And so in order to implement the file system, you need to define the functions of this structure with the pointers of your own implemented functions. So finally, my project, I wanted to create a simple file system implementation that reads the contents of a directory. So this function is one of the more essential functions in a file system. So this function mainly gets the attributes of the file, mainly what type of file it is and what to do if it's a directory or a regular file. And so mode specifies its type, whether it's a file, directory, whatever. And depending on that, it sets the permission bits of the file. Nlink specifies the number of hard links. And so if it's a directory, there's two hard links, one for like 1 dot and 2 dots, which is mainly a convention in the Unix world. And then size specifies the size of the file in bytes. This code implements the read directory function. Every directory has at least two entries, as I mentioned earlier with the 1 dot and the 2 dots. So say this directory has two files in it, file 2 and file 100, it should read in those two files and return 0 on success. This code implements the read function. There are two variables that contain the contents of each file, and depending on its path, it assigns content to its specified file. It then copies the contents of the file and returns the number of bytes. Everything went well up until the point of mounting the file system. I got an error that said Fuse missing mount point parameter. Did some research but didn't find much except that it's been reported as a bug in some cases. It's a really simple file system, so I like to think that it would have worked if I could have mounted the actual file system. To wrap this up, implementing a file system really helped to solidify my understanding of how it works. Most of my time was spent troubleshooting and trying to understand how the library actually works to bridge the user space code with the kernel interfaces. These are the resources that I used. Thank you for listening.